Hello everyone, welcome back to the sessions on the advanced communication. This is the session 5. Today's session we are going to learn about the working principle of the A-scope display and the working principle of the PPI display here. That is the displays which are used in the radar system. What is the radar display? It is an electronic instrument which is used for displaying the data. Visually is known as the display here. That is, for example, if you consider the basic principle of the radar, in case of the radar, we are editing the electromagnetic waves in the space and it is going to strike the target and we are receiving back the echo signals there. Therefore, those received echo signals are processed and those are analyzed whether the presence of the target and also the location of the target and also the whether it is moving or not, stationary target or the moving target here. Therefore, to make all those things, we need some form of the visualization about the know the information about the echo signal here. Therefore, to visually observe those echo signals, we are having the displays, and those displays which are used in the radar as called as the radar displays here. As an electronic instrument which is used for the displaying the data visually is known as the display. So the electronic instrument which displays the information about the radar's target visually is known as the radar display here. The display which is displaying the information about the echo signal, radar's echo signal, that is known as the radar display here. It shows the echo signal information visually on the screen here. Now, in the display system, we are having basically two types here: deflection modulation and the intensity modulation principles here. Usually in the deflection, in the laboratory, what we are using the CRO, that is made up of the deflection modulation, because whenever the input signal or the signal we want to measure, that is applied, what will happen? The electron beam will deflect and it will generate the waveform. It will shows the waveforms there and that is displayed there. Therefore, it is called the deflection modulation. But in case of the some type of the displays, whenever the input signal is applied, then what will happen? The intensity of the beam will changes there, whether the low intensity or the high intensity. Therefore, the bright spots are produced there on the screen. That is called as the intensity modulation type of the display here. Now the first one is the A-scope display, that is the radar's A-scope display here. A-scope display, it is then two-dimensional radar display. It is an two-dimensional radar display. The horizontal and vertical coordinates represent the range and the echo amplitude of the target respectively. That is the horizontal coordinate and the vertical coordinate that will represent the particular information here. For example, it is the two direction means horizontal direction and the vertical direction here. Right? This is the horizontal and the vertical direction. Now the particular information, suppose here we are having some form of the beep here. Suppose like this means if you are having this one, now this horizontal distance that in the horizontal plane that represents the distance, and this vertical, this will represent the amplitude of the echo signal here. This will represent the amplitude of the echo signal. Therefore, this is the horizontal plane and this is the vertical plane here. This is the horizontal plane and this is the vertical plane. This represents the distance from the radar station. At what distance the target is present here. Whenever the echo signal we are receiving, this is the echo signal here. This is the echo signal, and after receiving the echo signal, at what position the echo signal we are getting, that distance represents the particular distance from the target of the echo signal, and this is the amplitude, represents the strength of the echo signal, and this is the horizontal plane here. Now, the horizontal and vertical coordinates represent the range and the echo amplitude of the target respectively. Now in A-scope, the deflection modulation takes place. As I explained, there are two types of the technologies. One is the deflection modulation and one more is the intensity modulation. In case of the A-scope, it is the deflection modulation type of the display here. Means whenever the input is applied, the electron beam will deflects and it will produces the image there. Therefore, it is the deflection modulation type of the display here. It is more suitable for the manually tracking radar. This type of the A-scope displays are more suitable for the manually tracking radars here. Now, this is one of the waveform which we'll get from the A-scope display. If you observe here, this is the screen here. Now, this is the first pulse what we are getting. First, this one signal. This is the signal which we are receiving due to the transmitted signal here. The signals are transmitted due to that. This is the pulse represented on the screen. And after some time here, we are receiving the echo signal here. This is the echo signal pulse. Therefore, this distance from here to here, that distance represents the particular distance from the target to the information here. Here, this distance is there, no, this one here. From here to here, because this is the transmitted pulse here. This is the transmitted pulse, and this is the received echo signal here. This is the received echo signal. Therefore, this distance from this to this represents the what is the distance from the target to the radar station here. And in between, we will be having some noises here, clutters here. Those are due to the stationary objects here. The echo signals which we are receiving due to the stationary object, we are receiving some clutters here. Now, same way again here. This is the reference pulse, that is from the transmitted pulse here. And this is the nearby object clutters here. That is the whenever the near some buildings, some objects are there. Due to that also, we will receive the echo signals. These are those echo signals. And this is the target echo signal. That is the signal we are receiving from the target. Again, some ground clutters here. Again, from the some ground clutters here. Now, we'll move on to the next one, that is the plan position indicator. Next one is the plan position indicator here, that is called as the PPI display here. Now, this PPI display, this is making use of the intensity modulation technology here. In case of the A-scope display, it is the deflection modulation type of the technology. That is, whenever the input is applied, it is deflecting. The particular electron beam is deflecting. But here in case of the PPI display, it is the intensity modulation. Therefore, whenever the signal is applied, the intensity of the particular electron beam will change there. Therefore, we can observe the bright spots on the screen when the target echo signal we will receive there. Therefore, a plan position indicator is a type of radar display that represents the radar antenna in the center of the display. That is, it is having the circular type of the display here, and at the center of the particular circle will be having the display here. At the center of the circle will be having the display, which the distance from it and height above the ground was concentric circles here. That is from the center to the this one here. Now see here, this is the display here, correct? Now here from the center, it will be having the concentric circles here, like this will get. It represents the particular, suppose display that represents the radar antenna in the center here. Here at the center, the radar antenna represents, and with the distance from it and the here, will be having the concentric circle here from the center here. That represents the distance of the target from the radar antenna, and also the height from the ground to the that particular target. For example, this is the target is present, means what height it is the target is there. That also represented by these concentric circles. Therefore, wherever the target is there, they will receive some bright spots on the screen there. Now, as the radar antenna rotates, a radial trace on the PPI sweeps in the unison with it about the center point. Means, whenever the radar antenna rotates, therefore that particular target is traced here. The target is traced and the displays are formed here. That is, for example, you can observe the PPI display here. It is continuously rotating. Antenna is continuously rotating and it is sending the signals here. Now it is receiving the echo signals, and wherever the target is there, that time bright spot we can observe. You can observe here the bright spot. That is, wherever the target is detected, there will observe the bright spots. Again, from that the distance is measured here. Now here you can observe these are the particular permanent echoes due to the permanent objects here, stationary objects. Now this is the target blip here. That is, wherever the target will detected at that position, the blip will be observed here. Therefore, here we are getting the target blip here. Now these are the markers here, range markers. At what range, from here to here, what is the distance? From here to here, what is the distance? Like that, the distance can be calculated here. From this, we can make out the what is the position of the target. Now see here, same here. The antenna is rotating here, correct? The antenna is rotating, and wherever the bright spots we are observing, there the particular the target can be detected there. At that point, the target is present here because it is sending the echo signal there. Now same way here we are having the bright spot. The target can be detected at this particular point here, and the distance is from center because at the center the antenna is located. Now, this completes the session on the radar displays. That is, radar displays means the displays which we are using in the radar applications. Mainly two types of displays. One is the A-scope display, another is the PPI display. A-scope display is making use of the deflection modulation technology, and PPI display is making use of the intensity modulation technology. And in case of the A-scope display, it is that two planes it is using, horizontal and the vertical. In the horizontal plane, it is showing the distance, and in the vertical plane, it is showing the what is the amplitude of the echo signal. Similarly, in the PPI display, we are having the circular shaped display there. At the center represents the antenna position, and wherever the particular target is detected, we will get the bright blips there, or some bright spots there that represents the location of the target, and the concentric circles represent that particular distance there from where the target is located. In the next class, we will continue with the next session. Thank you.